All right, we've come to the last lesson in the exponents unit. Now, I know the notes say unit 7, day 7, but remember I told you we trimmed some stuff, so they're actually unit 7, day 5. We're going to turn things into scientific notation. So you've got standard notation, how you write numbers all the time, 47,190. But then we have scientific notation, which is 4.719 times 10 to the 4th. And that looks really complicated, but it's actually not. Now, remember we've done bases and exponents before, right? Well, we're going to call this the base right now. Now, the base in scientific notation has to be greater than 1 and less than 10. So it's between 1 and 10. If you're going to write scientific notation with a positive exponent, you're going to take your decimal, okay? And I'm going to put this in really, really, really fine writing, okay? You take your decimal and you're going to move it 2 places. So you're going to have 8.485. And you moved it 2 places. 2 places, I can spell, left. So it's times 10 to the second power. Because, let me show you. Remember that 10 to the second power is 100, right? So if you do 8.485, 5 times 100, you get 848.5. I'm going to put this in parentheses. That's our proof. So, however many places you move the decimal point, that is your exponent. However many places you move the decimal point is your exponent. Now we're dealing with positive exponents right now. So I'm going to put another note up here. Move decimal to left equals positive exponent, okay? And it also, it's a positive exponent. Now, on the right side, we're going to undo it. So here's what we're going to do. We have 7.82, and we're going to write it in standard notation. Now, I'm going to give you a hint. I'm going to write 7.82 in red because that's the number I was given. I'm just going to throw a bunch of zeros on the end because when you do that, you're not changing the amount. You're just changing the way it's written. Now, I have to move the decimal. I've got to move the decimal 3 places because I'm undoing the standard notation. So I'm going to move it 1, 2, 3. So my final answer is 7,820. It's just like saying 7.82 times 1,000. Because 10 to the 3 equals 1,000. So what we did here is we took standard notation, we turned it into scientific, and then we took scientific notation and turned it into standard. We've gone both ways with this. But let's go down to, the first example. Write 596,000 in scientific notation. Well, the decimal point will be at the end because it's nowhere else in there, is it? So now you have to, 1, move decimal to make base greater than 1 and less than 10. So let's do that. 1, 2, 3, 4, 5. I'll write that down. Moved 5 places. Okay, and 2, rewrite with power of 10. So this would be 5.96 times 10 to the 5th because I moved it 5 places. Okay, let's undo it. Let's write 3.45 times 10 to the 6th in standard notation. 1. Rewrite with a bunch of zeros. Because you don't know how far you're going to go. So I'm going to write it over here. 3.45, 1, 2, 3, 4, 5. I'm just putting 6 there. I know I don't need that many, but I'm just putting 6 there. 2, move decimal. Write number of exponent. I'll do that in blue. There's the decimal. We'll make it big. Okay. Now our exponent here is 6, so we're going to move it to the right 6 places. 1, 2, 3, 4, 5, 6. So my final answer is 3, 4, 5, and I've got 4 zeros. 3, 4. Isn't it a whole lot easier to write 3,450,000 in scientific notation than standard notation? So this isn't complicated. There's no real math going on here, but you have to remember to keep track of your decimal place. All right, now we're going to go to the next page where we're going to write with negative exponents. Okay, now the scientific notation rules stay the same. You still want your base between 1 and 10. All right, it cannot be less than 1. It cannot be more than 10. And you're still going to move your decimal back and forth. But now, if you notice, look at the scientific note, the first thing we have. It's a super, super, super small number. So when you have to move your decimal to the right to make a super, super, super small decimal number bigger, that means it's a negative exponent. So let's do what we've been doing. Let's count how many places we have it to get our base. We move it 1, 2, 3, 4. And folks, I have always done it with my little loops, and I'm always going to do it that way. So I have 2.57 times 10 to the negative 4. It's negative 4 because I made a teeny tiny number bigger. I made a teeny tiny number bigger. And move to the right. It's a negative exponent. When you write scientific notation with a positive exponent, you're taking a very large number with a whole bunch of zeros and you're making it smaller, easier to deal with. When you move to the right and you've got a negative exponent, you've got a teeny, teeny, tiny number. It's a whole bunch of numbers past the decimal point. Really, really small. You're making it bigger to deal with. That's a negative exponent. Okay, now let's undo it. We undo the same way we undid the other one. You move the decimal places. I'm going to write it with a bunch of zeros. Oh, let me show you. I know it's a negative exponent, so I know my zeros are going to be going in front of my number. I'm going to write that down. Negative exponent means zeros in front. Okay? Now let's move it. I'll move it in green. Negative 5 is my exponent, so I'm going to move my decimal 5 places to the left. 1, 2, 3, 4, 5. Goes right there. My final answer is 0.1234523. I'm just double checking, making sure I counted properly. 1, 2, 3, 4, 5. I did. See how small that number is and all those zeros in front, it's very easy to make a mistake on a calculator or on paper, which is why we put it in scientific notation. It's a whole lot easier to work with 5.233 times 10 to the negative 5 than it is dealing with 0.00005233. All right, more examples. We're going to write these in scientific notation. Okay, now what was the first rule last time? What did we say? Oh yeah, 1, move decimal. So 1 is less than the base, which is less than, the base is greater than or equal to, should be greater than or equal to actually, because it can be 1. And I'm going to go ahead and correct that up there. It can be 1, but it can never be 10. All right, so we do that. So I'm going to write it over here. 0.000441. So I can move my decimals. It's just easier when I can do it bigger. I have to move it 1, 2, 3. I have to move it 4 places. 4 places. And 2, rewrite with power of 10. So I rewrite it as 4.41 times 10 to the negative 4 because I took a super small number and made it bigger. And let's do the next one. 1, add zeros to the front. I'm going to rewrite it again. 1, 2, 3, 4, 5. Because why not 5? 3.23. Okay? Adding zeros in the front is not changing the amount. 2, move decimal. Exponent numbers. Exponent number of times. So I'm going to move it. I've got negative 4 is my exponent, so I'm going to move it 1, 2, 3, 4 times. My final answer is 0. I always do that so I don't lose track of it. Let's see. 1, 2, 3, 4. 1, 2, 3, 3, 2, 3. There we go. We'll practice it some more in class, but you just keep track. Moving left and right can sometimes get confusing if you're trying to memorize that as to whether you're using a positive exponent or a negative. So I think it's easier to remember if you're making a very big number smaller, then it's a positive exponent. If you're making a very small number bigger, it's a negative exponent. All right.